Let's find the integral from 0 to pi over 4, secant squared over 1 minus 9 tangent squared. First, notice that 1 minus 9 tangent squared is equal to 0 for some x value between 0 and pi over 4. So we need to split this up into two separate integrals. But first, to figure out what point we would need to split it up by, we need to set this equal to 0 and then solve for x. So you get tangent is plus or minus 1 over 3. So x is inverse tangent plus or minus a third. And we know that inverse tangent, the range is between negative pi over 2 and pi over 2. So it's somewhere in here. But because it has to be positive, we need to be looking in the first quadrant. And positive 1/3 is going to be the one we're interested in, because that's going to put us in the first quadrant. So we're going to split this up from 0 to inverse tangent of 1 over 3, secant squared 1 minus 9 tangent squared. And then we will continue from inverse tangent 1/3 to pi over 4, and then secant squared over 1 minus 9 tangent squared. So it's really important to break it up at the point where the function is not continuous. So I'm going to focus on the first integral. I claim that I don't need to do anything with the second integral, and you'll see why. So in order to solve this integral, I'm first going to do a u substitution. So we'll set u equals tangent, and then du will be secant squared. So secant squared dx is just du over 1 minus 9u squared. And here when x equals 0, tangent of 0 is 0. And then when x is inverse tangent of 1/3, tangent is just 1/3. Because tangent of inverse tangent will cancel, and you're left with 1/3. And if you want, you can still do it the other one. So there'll be 1/3, and then with tangent pi over 4 is just 1. And so this will be du over 1 minus 9u squared. So I claim that this second integral is not needed, and you'll see why. Okay, so let's continue this, and let's make v equal to 3u. So then dv is 3 du. So now keep in mind, these are in terms of u right now. So if I plug in u equals 0, I get v is 0. Plug in u as a third, I get v is 1. And then du is just dv over 3, so I can put the 1/3 outside. Get 1 minus 9, and then u is just v over 3 squared. So that simplifies to 1 minus v squared. And from here we can do partial fraction decomposition, because we know that 1 minus v squared is just 1 over 1 plus v, or sorry, 1/2. Let's do this. So it's 1/2 over 1 plus v, and then minus, or I guess we could say plus 1/2 over 1 minus v dv. But instead, I should have written like this. We'll say 1/2 v plus 1 minus 1/2 v minus 1. This form is easier to integrate, because we know that the natural log of 1 over v plus 1 is just ln of v plus 1. And then 1 over v minus 1 is natural log of v minus 1. And then going from 0 to 1. But because if I plug in v equals 1 over here, I get ln of 0. I cannot, that does not exist. So what I need is a limit. So I'm going to say limit as, let's say b approaches 1. And it's going to be from the left, because we're going from 0 to 1. So we have interval from 0 to 1. So if you're starting at 0, you're going to approach 1 from the left, obviously. So So that's why we have the left here. And then we have, I can factor out the 1/2 out here, so that will just turn into 1/6. And then we have ln of b plus 1 minus ln of b minus 1. That's going to be the first one, minus ln of 1 minus ln of the absolute value of 0 minus 1, which is just ln of 1. And we know that ln of 1 is 0, so actually both of these guys are 0, because this is ln of 1 as well. So I don't really care about it, in other words. So I can just focus on this, and then so if I plug in 1 here, so I guess what we could do, we know that this right here is ln of 2. We have a 1/6 outside, and then minus ln of b minus 1. So ln, I guess this will be the absolute value. So let's see. At x equals 1 here, there's an asymptote, and let's see, this is going to look like something like this. And then to the left of 1, it's going to look like this, because it is the absolute value, ln of absolute value b minus 1. So this will be b, this will be the natural log of absolute value b minus 1. So as we approach natural log of b minus 1 from the left, that's clearly going to go down to negative infinity. So what I have now is something positive plus infinity times 1/6. Obviously, this is going to be infinity. So what that means is the first integral is infinite. So in other words, this diverges. So I don't really care what this integral equals, because it's already diverging over here. So it's not like it's going to cancel it out and say that it's going to converge. So we stop here and say that this integral diverges.